Okay, so this is exam 3, spring 2013, question 8. And this concept is accumulation of change. Accumulation of change, in other words, it's that numerical, definite integration stuff that we did. In fact, this example was given in class, and sometimes I just do that. So, okay. The yearly rate of change of the world's population in millions of people per year is given in the following table. So notice it's the rate of change of millions of people per year. So notice the time steps are every 10 years. This is 10, but the units are in terms of per year. So we're going to estimate the total change in the world's population. So let's do an underestimate. Okay. First of all, we're going to look for the years 1950 to 1960, and maybe I'm going to just arrange this a little differently. I'm going to go like this: underestimate and overestimate. So if between these 10 years, the rate of change is 37 to 41. So let's say 37 times 10, and these are in millions, and overestimate would be 41 times 10. I'm going to pause this so I can fill in this table. Okay, I'm going to fill in some of these while I tell you what I'm doing, because I want to make sure you're clear on what I'm doing here. The next two years I'm looking at are 1960 and 1970, and all the intervening years. And between these 2 years, between these 10 years, 41 is probably the lowest the change per year is in millions, and 78 is probably the overestimate. Okay, and I'm going to march this down to the next window. And now what? Well, 78 is still the highest estimate, but 77 is the lowest estimate. And who's to say that somewhere in the middle it didn't go up to 80? Maybe it did. But we're just doing the best we can with the information we have. That we're not going to make any big changes to the data here. 86 versus 77. Now notice it's not strictly increasing or strictly decreasing. It goes up a little bit, goes down a little bit. And so we have this situation here where we can't just take a bundle like we did last time. We took this bundle, something like that, and added it up, and then we're able to slide it around. We actually have to add each of these up. And so we can go ahead and add each of these up, but I think I did this in class. So but I did it differently in class. Okay. Well, at least I did it differently in my notes, but might have been each year I do it a little differently. Okay, so let's go ahead and add up these underestimates. And, I'm going to pause this. I'm going to do this without you. Okay, because you just don't need to watch me adding numbers that might not even be right. Okay, so let's say the underestimate, they're definitely not right. Let me see if I can fix that. Okay, yeah, see, I added that wrong. That was an obvious mess up because the overestimate has to be bigger than the underestimate, and these guys are in millions. Okay, and so the total change is somewhere between these two values. So if the world population was 2555 million in 1950, so the beginning of our interval, and in 2000 it was 6085, well then we just go 6085 minus 2555, we pull out the calculator again, 6085 minus 2555, and we get 3530 million. Okay, and how does this compare with your estimate? Well, this is awesome because we have 3110 was our underestimate, and the real value is 3530, and the overestimate was 3690. So it's perfect. There's lots of other things you can do to get full credit, but this was what I was hoping people would do. And I think it's what basically nobody did. But a lot of people did answer this question and get full credit by saying other intelligent things. But anyway, that was what I was hoping people would be saying.